All right, today we're going to demystify a concept that is quite literally the backbone of so much modern software: object-oriented programming, or OOP. And by the end of this, I promise it's all going to click thanks to one really simple analogy. I mean, really think about it. Your favorite social media app or some huge online game. We're talking millions of lines of code. How on earth do developers keep all of that from turning into a total tangled mess? Well, the answer lies in a really structured way of thinking.
They use an approach that works a lot like a digital assembly line. And for the next few minutes, we're going to run with that idea. We're going to use the concept of building a car to see exactly how this whole assembly line, object-oriented programming, really works.
Okay, so every single assembly line has to start somewhere, right? It starts with a plan, a master design, and in the programming world, we call that master design a class.
A class is the blueprint, and it's super important to get this. It's not a physical thing. You can't touch it. It's the detailed set of instructions, the specifications for how to build something. It lays out all the potential features and functions before you even start.
So, sticking with our car analogy, the class is like the complete design file for a new car model. It specifies everything. It's going to have an engine, 4 wheels, doors, you name it. But here's the catch. If you're just holding the blueprint, you can't drive it to the store, can you? It's just a plan.
And check this out. This is what that whole blueprint idea looks like in actual Python code. See that? The keyword class, followed by a name, in this case, person. That's basically us telling the computer, hey, get ready. I'm about to hand you the blueprint for creating people inside my program.
Okay, so we've got our blueprint. Now for the fun part. It's time to fire up that assembly line and actually build something tangible from that plan. And this right here, this is the key distinction you need to remember. If the class is the blueprint, then an object is the actual car that rolls right off that assembly line. It's a real, tangible thing that exists, and it has its own unique properties, like a specific red paint job or its own unique vehicle ID number.
In code, this is that magic moment of creation. When we write P equals person 𝙒𝘀𝘽, what we're really saying is, hey computer, grab that person blueprint and build me an actual person. And by the way, her name is 𝙒𝘀𝘽. That little variable P, that's our brand new object.
Okay, but wait a second. How does that actually happen? How does this new object get its own unique details? How does our car get its specific paint color? Or how does our person object get the name 𝙒𝘀𝘽? Well, it all happens with a special, kind of magical method called __init. The best way to think about it is like it's the moment a car's engine is turned on for the very first time on the assembly line. It's this automatic process that runs the instant an object is created, and its whole job is to assign all those initial specific properties.
All right, so we've got a fully assembled car. It's got its own unique details. Great. But, a car isn't very useful if it just sits there. It needs to be able to do stuff.
And those actions, we call them methods. A method is really just a function that belongs to a class. It's part of the blueprint, defining all the behaviors, all the things that any object made from that blueprint will be able to do.
So if our object is a car, its methods are all the things you can do with it. Think accelerate, brake, or honk_horn. These are the car's built-in capabilities, right there in the design.
And for our person object, it might have a method called greet. So when we tell our object P to greet, it uses its own specific name, 𝙒𝘀𝘽, to introduce itself. You see? It's an action that's tied directly to that specific object's data.
Okay, now we're going to get into two really powerful principles that make OOP so darn efficient and safe. Basically, how can we reuse our designs for new models, and how do we protect the complex guts of our creations?
First up, we've got inheritance. Okay, so imagine you've spent all this time designing a great blueprint for a car. Awesome. But now you want to design an electric car. Do you have to start all over again? No way! You can just inherit all the features from the original car blueprint. The wheels, the doors, the steering wheel, and then just add the new electric-specific stuff. It's an absolutely brilliant way to reuse code. Next up is encapsulation, and this is all about hiding complexity. Think about it. You don't need to be a mechanic to drive a car, right? That's because the super complex engine is encapsulated under the hood. All you get is a simple interface, the pedals and the steering wheel to make it work.
And we do the exact same thing in code. We make certain data private, and you can often spot it by those double underscores.
Here, the ___ balance of a bank account is protected. Other random parts of the program can't just reach in and mess with it. They have to use the proper, safe methods like deposit or withdraw. It's just so much safer.
All right, we've made it to our final core concept. And this one is a bit of a mind bender at first, but it is incredibly powerful. It's called polymorphism, which is a fancy word that literally just means many forms.
Okay, so let's say we have a blueprint for a cat. Part of that blueprint is a method called speak. When we create a cat object from that blueprint and we tell it to speak, it says meow. Makes sense, right? Simple enough.
Now get this, we have a totally different blueprint for a dog. But it also has a method with the exact same name, speak. And of course, when we tell a dog object to speak, it says bark.
And that is polymorphism. The same action, the same method name, speak, gives you a different, totally appropriate result depending on which object you're talking to. This is what lets us write super flexible and clean code that can handle all sorts of different objects without getting confused.
So there you have it. From that first blueprint of a class to creating unique objects and organizing them with these powerful ideas, you now get the real essence of object-oriented programming. It's really just a way of thinking, a mental model for taming complexity. Which kind of leads to a final thought for you. What other kinds of blueprints do you use in your own life to manage complexity?